Hello and welcome to another tutorial video. This video I'm going to talk about a Blender plugin. Now you might already be aware of it, but basically whenever we're working with anything that we need to bring into Spark AR, it's all about optimization, optimization, optimization. That is for how we optimize our images, how we bring in our 3D models and reduce the polygon counts, how we basically compact and compress everything we can to meet the quite stringent and fairly small sort of maximum size requirements that were allocated by the generous people at Facebook and Instagram. So in this video I'm just going to talk through how to install the Spark AR Blender plugin, how it works, and show it in action basically. So hopefully this will go well. I have already attempted to record this video, but my computer decided to have a meltdown, so let's see how this time things play out. Okay, so as I sort of mentioned in the introduction, everything that we do with Spark requires us to optimize everything we do. So when we're working with 3D models, you can imagine that the complexities, the sort of scale, the amount of data that needs to be crunched and compressed in order for an Instagram filter, a filter that basically has to run on a mobile phone that doesn't necessarily have to be an iPhone 12 or a £1,000 phone of any description. You know, it needs to be able to be optimized, it needs to be able to be streamed through a download service, and it needs to be around the 4 to 10 megabytes depending on the kind of format you're deploying it to. So we can't have anything too elaborate, especially if we want to have a 3D model with particles, sound and all that jazz. So we need to optimize, and luckily Facebook and Instagram team basically have created a dedicated plugin for Blender that does basically just that. So what I've got here is just this 3D model that I found online of a Mandalorian helmet. It's about 207,000 or 707 sorry. So this Mandalorian helmet here is 330,000 vertices. It's 661,000 faces. So it's quite compressed. If I actually just show you the mesh for a second, just the wireframe, look at how detailed that is in regards to the amount of little polygons, the triangles, the amount of data, and each of those points have to be rendered essentially. So we need to compress the hell out of this in order for Spark AR to even be able to take it in. So when we download Blender, we have access to a variety of plugins. So if we go to Edit, Preferences, and we go to our add-ons window here, you'll notice that it comes with a plethora of official and community add-ons essentially. But if I was to type in Spark, there doesn't include a Spark plugin. That doesn't mean there isn't one. In fact, to find it, we need to basically do a good old Google search, and we need to search for the Spark AR Toolkit for Blender. Now, luckily, if you see a page like you see on screen right now, it kind of goes through the entire installation process for you. So I will go through this very briefly. But essentially, all I want to do is download this zip format, this zip file. I want to go back into my Blender project, go to Edit, Preferences, Add-ons. I'm going to go over to the Install option, navigate to my downloads, and then I want to find my zip folder. So this is the Spark AR Toolkit.zip. I do not want to extract that zip folder, I want to actually import the zip folder as is. And I'm going to click Install Add-on, keeping the default target path. And what this will do now is add on a new little plugin. So it should be Import Export Spark AR Toolkit. If I click that little box to enable it, like so, nothing looks like it's happened. But if I was to close this window and go over here to my little arrow at the side, we should have Item, Tool, View, and most importantly, our Spark AR Toolkit window. Now, if I was to select my model here, this will tell me all the information and basically allow me to start optimizing the hell and crunching this model as much as possible. So you can see here is 661,000 triangles. That is a ridiculous amount. We need to compress that a lot. And the point and the kind of game we're trying to play here is we're trying to optimize, compress our models whilst trying to retain as much detail as possible. So again, I can't give you exact figures here, but we need to try and keep it to a kind of certain parameters. If we was to click here to learn more, it actually would tell us those parameters. So I'm just going to reduce this to, let's say, 80% and see what that does. And hit enter. And this may take a bit of time for my computer to sort of catch up and start processing that information for me. So you can see now it's reduced it to 132,000. It's still too many. So let's try 90%. And again, this is going to take a little bit of time. 66,000, still a bit too much. Let's try 95% and see what that does. So ideally I'm looking for around 49, below 50,000 kind of remit. Let me just turn back our rendered view back on. Like so. So again, there we go. So what we've got here, in fact I'm actually just going to, there we go. So what we've got here, we should find all principles, it looks exactly the same, it looks the same details there. We may have lost a little bit of kind of sharpness around the edges, like here you can see there's a bit of stippling where we're kind of getting this like triangling overlapping thing. That's not quite right, that's because it's basically compressing and stitching together those vertices together. If I was to go back to my rendered view, you can see here that the smoothness of the helmet is no longer there. It's actually looks like this sort of spider web, this kind of pattern of kind of small squares forming up this what on the surface looks smooth but actually is sort of lumpy now kind of optimization going on. Now the thing we've got to remember is when we're making a filter for Instagram or Facebook, we're going to be viewing it on a mobile phone typically, so we don't necessarily need to achieve the kind of same levels of quality and realism that we would if we was viewing this on a large screen monitor or TV, for example. So we do have to sort of accept certain losses of quality. Another thing we can do is also to kind of help to reduce our file sizes is we can also hit the cleanup mesh. So that will remove any erroneous kind of sort of part of vertices. It will try and crunch together things. It will remove things that we're not going to see basically, and just try and again optimize as much as possible to reduce our file sizes. So I'm just going to hit that as well. And again, on the surface it won't necessarily look like it's done much, but this will again allow Spark AR to be able to read this more effectively and allow your filters, your effects to look a lot smoother and track a lot more reliably. Another thing we can do is we can adjust the scale. So we can adjust it either in centimeters, inches or feet. I'm just going to reduce this. Again, depending on how good your computer is, depends on how long this will take. So in fact, you may actually just want to scale it using the transform options over here. So let's just see how this goes. My computer might throw a hissy fit at this. So I'm just going to adjust my scale a little bit in the transform options, just to sort of make this a bit smaller, because otherwise when I bring this into Spark AR it will be fairly large. So 0.5, 0.5, 0.5, so I've halved it from the original sort of scale. And at this point here I could hit export mesh and it will now bundle that model up and any textures that we've created and allow us to then import that as a .glb TF into our Spark AR project. So what I'm going to do now is I'm actually going to create a sort of little companion video that will be in the video description, which is where I'm just going to quickly create a reflective material shader for this helmet. So the reason I'm not going to necessarily show you how to do that in this video. So again, this will sort of, you'll see me kind of speeding through this. If you want to see how that's done, check the little add-on video in the description. And I will also address how materials behave differently between how they look in Blender and how they are treated within Spark AR at the end. But so yeah, for now I'm just going to whiz ahead and create my reflective material. Okay, so we have now, as you can sort of see, we whizzed through and added this reflective material to our helmet. You can see how the kind of optimization has had an impact on the reflection. Again, the less we optimize, the more smooth and reflective that will be. There's a balance between the kind of quality and optimization and performance. So I'd rather typically go for performance over visual fidelity. But you can kind of, again, you know, with a bit of work, for example, this 3D model here doesn't necessarily even need the back of the helmet, because when you're 3D tracking a helmet on a person in Spark, you can't actually track the back of a person because it only tracks the face, or it needs a point of reference to track. So realistically, we only need a model that kind of goes from the kind of probably the ears around to the front. Anything kind of at the back is superfluous. So if we used to move any sort of triangles or polygons at the back of this area, that would reduce the number of vertices and our count essentially, and that in itself would be optimization. And we could even then reduce, you know, not have to be as extreme on the optimization or reduction on this model as we have had to be in this case. So what I'm going to do now is I'm just going to adjust my pivot point. So you've got two options, one for center, one for bottom. Whenever we're working with anything in Blender, any 3D models, we want to try and origin everything ideally to 0, 0, 0. So you notice that my location for my model is set to 0, 0, 0. If my model's location point or pivot point when I import it isn't actually at 0, 0, 0, I can move the model to that position manually by dragging the pivot point wherever that's located. And then right click on the model, right click, set origin, and set to the geometry. And that can then reset and create us a new pivot point within the middle of the model rather than offset elsewhere, for example. So for a helmet, we would like to set the pivot point to be the center. So again, this is going to take a little bit of time on my computer because it's having to go through a lot of thinking processing at the moment. I say thinking processing, it's basically what computers do. There we go. So with helmets or sort of anything that goes on the face, we ideally want the pivot point to be in the exact middle, so where our nose would be essentially. If it's something that we're going to be tracking onto a target or a surface, we want the pivot point to be on the bottom, so the model is above it. Likewise, inverse if we're having something that's going as a kind of exclusion in regard. But for helmets and anything on the face, typically we'd have the central pivot point or the middle point of origin being the exact middle of the object, both on the X and Y axis and obviously the Z as well. So once that's set, I'm just going to again click on my model, hit export mesh, and I'm now going to save this onto my machine and put this somewhere sort of sensible. So I'm just going to, for the time being, put this on my desktop. Not good practice, but I'm not one for good practice always. Okay, so I'm now just going to give this a name, so I'm going to call this Mando Helmet Tutorial. Keep everything to default, so we're not adjusting any of the properties. We're just going to press export mesh, and this will now compress this .gltf 3D model and package alongside it its material alongside the environment that's kind of bundled within Blender. And now at this point we can open up Spark AR and start importing this model and working with it like we would with any other mesh. So that's what I'm going to do now. So I'm just going to open up Spark AR Studio. I'm just going to create a new project. I'm just going to create a face tracking project. Now, this helmet won't track perfectly. I won't be able to have the helmet actually around my head because I'm not using a head occluder in this tutorial. That's another tutorial I've already covered before, and there's already templates within Spark AR Studio that we can use, that we can just bring the model into to do that. And again, if I was to do this properly, I would want to actually, like I said, remove the back of the helmet, because why would you want the back of the helmet when you can't see it? Because no viewing angle would allow you to see the back of the helmet and still track your face. So I'm just going to now import my model by dragging it into my Spark AR project, like so. And if I open this up, you'll see we've got our 3D object, we have our material, which is assigned to that 3D object, we have our 360 HDR image, so we can actually replace that, so that can be, we can replace the reflection that's being projected onto that material. And I'm just going to drag my helmet onto my face tracker object, like so, and you can see here the scale is well off, basically. Luckily I can still adjust the scale within Spark AR, so I'm just going to do that first. In fact, I've probably been a bit extreme with the scaling down here, so let me just play about with the values until it sort of looks right. Nearly there. That'll do. It's not perfect, and again, like I said, we would obviously want to use a head occluding template if we used to do this properly, but I'm just going through the process of what the toolkit, so the process of bringing a model into Blender, using the toolkit to optimize it, and then bring it into Spark AR. So let me just move my model into kind of the position I'd expect. Again, like I said, it's not perfectly going to match because I haven't used the head occluder. Now, this is where, if you watch the kind of companion video down in the description, remember when I sort of said earlier that materials from Blender, once we bring them into other programs such as Spark AR, don't necessarily behave the same? This is a perfect example right here. So this helmet that we've seen in Blender has this reflection, this kind of reflective shader applied to it, this surface that projects this environment map onto. But when we bring it into Spark AR, it's not there, it looks grey. If I was to select my material that's associated with that helmet, you can see we've got it physically based here. If we go to our environment, you can see that our default environment is applied, but it's not showing up. And the reason it's not showing up is because it's actually increased the roughness upon import. So if I was to drag this roughness back down, like so, you can see that now this has brought back the reflection, it's brought back this sort of mirror ball, this kind of mirrored effect that's going on. I can still change the material that's being reflected on that surface, I could rotate that material around, I can animate any of the values within Spark AR as I would any other project, and at this point everything is the same as we would work in any other projects in Spark AR. And it's just that process of drilling down the idea of optimize, optimize, optimize. Optimize textures, optimize models, optimize audio, optimize your project, optimize your life, basically. And yeah, we have to compromise sometimes between quality and performance. It's more important that your users get a smooth experience than they get a super fancy, flashy, does everything. It's no good if they're getting 1 to 2 frames a second, for example. So good user experience should always come first over aesthetic appeal. Anyway, hopefully this kind of has been useful. You might already be aware of the Spark AR Toolkit. If you wasn't, I hope this kind of highlights the fact that it's a free plugin that you can get. There are many optimization tools out there. For example, things like Photoshop, you quite often will actually want to scale images down a lot smaller than you would think. And you can still preserve the quality that way. But yeah, I will be doing some dedicated Blender tutorials on how to do things like work with shaders, materials, 3D models optimization, creating 3D assets in the future. Remember to check out my full Spark AR playlist at the end of this video. And remember to like, comment and subscribe, and I will see you all very soon. Goodbye.